All right. This next question really is going to summarize some of the strategies that we've had through the last couple sections, and we'll talk about that in a minute here. Let's go ahead and read the problem. So the second graph represents 6x plus 9y equals 75. It describes the relationship between the pounds of almonds and pounds of figs and the dollar amount that Claire spent on them. Recall we had talked about this situation in a few sections back from here. Suppose a classmate says, I'm not sure the graph represents 6x plus 9y equals 75 because I don't see the 6 or the 9 or the 75 on the graph. How could you show your classmate that the graph indeed represents the situation? Now, they're not saying that they literally don't see the number 6 or the number 9, but rather they're talking about the graph, the line itself. You know, you don't really see a 6 or a 9 or a 75 represented by the line itself. You know, that's one of the things, and there's a lot of situations in which these standard form equations are helpful and easy to write, but when we actually graph it, sometimes we lose that connection and we're not really sure, how those numbers are shown within the graph itself. So if this is a moment in which you would maybe be able to pause and just kind of think through this question for a moment, that would be great. I'm going to continue to talk about it, but I'm going to recommend, if you're listening to this on video right now, that you just pause the video right now and just think about this question. How would you show your classmate that the graph indeed represents this situation? All right. Hopefully you took some time to think about that. And maybe some of the things that I am going to talk about were things that you thought about, because there's different options for showing how this graph might be represented by this equation. All right. And I'm going to think of these as options, things that you could do to show that friend. Option number one, let's think about a point on the line. If we have a point on the line and we put it into the equation and it works, then that might be good enough evidence to show that the equation matches up with the graph. And maybe we take a couple of those points to really emphasize that. This goes back to kind of the beginning of the unit. If a point is on a line and it works, then that equation represents that particular line. All right, so take a point or two, I'm going to recommend two actually, on the line and substitute them into the equation to see if it is true. All right, so let's take a point and see if it works. I like to scan down my line. Okay, here's the first one as I'm going from left to right, where it goes right through the corner of one of my grid squares. So that's the point 27. So let's put 27 into our equation and see if it works. All right, so that would mean 6 times 2. Remember, I'm using this equation, so I'm putting the x value of 2 in for x, and I'm putting the y value of 7 in for y. Okay, does that work? 6 times 2 is 12, 9 times 7 is 63, 12 plus 63 is 75. Yes, it works. All right, but we could have a different line that goes through that same point. So let's just double check by finding another point. Let's just continue to go down the line. Okay, here's another one. All right, that's the point 5, 5 actually. So let's take the point 5, 5, see if that works. So same equation, 6 times 5 plus 9 times 5, does that equal 75? Well, 6 times 5 is 30, 9 times 5 is 45, 30 plus 45 is 75. So yes, and we could continue to do that, but we've shown now that 2 points that are on that line work and make the equation true, and so that would be evidence that this graph is represented by this equation. Okay, so that's option number one. Okay, maybe that was one of the things that you talked about. Option number 2. Should we change colors? Why not? Option number 2. All right, we talked about using intercepts and seeing if those match up. And this is going to, maybe get at some of the direct values of some of the points that we see in the graph. So let's think about the y-intercept. How can we figure out a y-intercept? Well, we know a y-intercept has a 0 for its x value. It's always 0 something because it's on the y-axis here. All right, and this one looks like it's a little bit above 8, so it's going to be 0, 8 point something. All right, we can see that. So let's put that in the equation and see what we get. So put 0 in for x to see what we get for the y-intercept. Uh-oh. Got some action over here. No, this always happens when I'm recording a video. We have some other action going on, so I'm going to put the dog down. He's very excited to see someone. So hopefully you're entertained by that. All right, so if we put 0 in for x, what do we get for the y-intercept? So let's put 6 times 0 plus 9y equals 75. All right, so if we're solving for y, 6 times 0 is 0, so that leaves us with 9y is equal to 75. Dividing by 9, we get y is equal to 75 divided by 9. Now you might note that's not going to work out evenly. If you take 75 divided by 9, you get a little bit over 8 though. It's actually 8.3 repeating, or 8 1/3. So our y-intercept is 0, 8.3 repeating. And we can see up here in the equation, that does look like that matches up. So yes, it matches the y-intercept. Okay, so that is an option. All right, as long as we talked about y-intercepts, let's talk about x-intercepts. So if we talked about x-intercepts, that's another option. So an x-intercept is always going to have a y value of 0. It's kind of like the opposite, right? Because if you think about this x-intercept, which by the way is a little bit over 12, it's got 12 point something 0. So we could put 0 in for y to see what we get for the x-intercept. All right, so let's see right here. So that means we have 6x plus 9 times 0. Remember, putting 0 in for y. And then solving that. 9 times 0 is 0. So that leaves us with 6x equals 75. And dividing by 6, x is equal to 75 divided by 6. Which again, doesn't work out perfectly evenly. It's a little bit nicer though. If you take 75 divided by 6, you get exactly 12.5. So in other words, our x-intercept is 12.50. Does that match up with our graph? It certainly looks like it does. It's between 12 and 13. It looks like that is. All right, so yes, it matches the x-intercept. Okay. Is your friend convinced yet? Because we've showed a lot of convincing evidence here. Evidence is great. I'm going to show you one more, so let's just stick with this for one more little slice of evidence, and maybe you did this. So one thing we could do is take our equation and rearrange the equation and solve for y. In other words, get it into its intercept form, and then maybe we can see more information about graphs. So let's solve for y to get y equals mx plus b equation. And then we can check out what we get for the slope and the y-intercept. So our equation was 6x plus 9y equals 75. All right, so if we're solving for y, that means we're going to get y by itself. Let's start off by moving that x over to the other side of the equation. Since it's a positive, 6x, we will subtract it, cancel it out from the left side. Over on the right side, remember those are not like terms, so we keep them separate. And then divide both sides by 9, and here's kind of where our warm-up came in today. So 75 divided by 9, and then 6 divided by 9. 75 divided by 9, that should sound familiar. We just did it up above a little bit. That's that 8.3 repeating. And then negative 6 divided by 9, if we reduce 6/9, that's minus 2/3. So here is our y-intercept. So that matches up. And then our slope, is our slope really 2/3? Well, let's go back up here. I don't know that we've really talked about that much, but we do have 2 points that we noted earlier, and let's just check out what the slope is. So what's happening here as our rise? So it looks like we're going down 2, and then we are going over between 2 and 5, so we are going over 3. So rise over run is negative 2/3. That is our slope, and lo and behold, that matches up with what we have here. So negative 2/3 is the slope. So we have now shown that we can actually see, if we just rearrange the equation into its intercept form, we can actually see that this equation does have a y-intercept and does have a slope that matches up with that line. So any of those possibilities could have worked. You have lots of different options now. This is a great page to keep for your notes for studying later, either in the week or the unit, whenever we get to formatives or